Alright guys, today we are going to look at one of the more simple projectile motion type problems. Guys, we've worked on constant velocity type stuff, we've worked on acceleration type stuff, both in the X and the Y direction, and now we're going to combine them together. Okay, so we start off with kind of a classic problem. I picked Joe because he's our soccer guy. Joe kicks a ball horizontally off an 18-meter high cliff with an initial velocity of 20 meters per second. So, guys, here's the ball. He's kicking it. Oh, geez, I'll have to draw Joe. This is going to be painful.
Get the red marker out.
Okay. I think I got one. You can draw Joe. Okay. There we go. There's Joe. He's kicking the ball off the cliff with an initial velocity in the what direction?
Horizontal.
It's horizontal, so we call that the X direction of 20 meters per second. Okay? You get the idea. Now, we all know that the ball is going to, once it goes off the cliff, will be under the influence of gravity. And so gravity is going to start to accelerate it in the Y direction. We learned last week that in the X direction, it should always be going what? 20, 20, 20. It's always going to be going 20 in the X, right? And so if we were to draw little vectors, we would know that it's always going to be 20. Here it's going to have some Y velocity. If we got here, it's still going to be 20, but the Y velocity is going to have gotten bigger, right? Does that make sense to everybody?
Yeah.
Okay. And then eventually, right before it hits the ground, we know it's going to have 20 here, and then some V final in the Y direction, which once we find that, would give us some sort of estimation of what our final velocity is, combining our X component, our Vx, and our Vy, and then we'd have to find some sort of theta. So we'll eventually get to that at the end of this problem. Okay? We have a cliff that's 18 meters high, and so we're going to answer these questions. How long will the ball be in the air? What's going to influence how long the ball is going to be in the air? Basically how high it is, and acceleration due to gravity, right? Does that make sense? Now we're going to assume there's no air resistance like we do in almost every problem, and so we can figure that out really easily using some kinematic equations. How far from the base of the cliff does the ball hit the ground? So we're going to be looking for that in part B. And then in C, what is the velocity of the ball the instant before it hits the ground? Which is, we're going to be looking for that right there. Okay? So if we come over here, guys, well, you know what? Let's come here. In the Y direction, we know that V naught Y is 0. This is pretty big. If there's anything that kids mess up on tests, it's that getting confused. This is V naught X. In the Y direction, he's kicking it horizontally, so in the Y direction, it's V naught Y is 0. Does everybody see that? That's pretty important. Okay? So V naught Y is 0. AY is 9.8 meters per second squared. That's acceleration due to gravity. And then the Y is 18 meters. Okay? Now, some kids might ask, Mr. Lennick, why did you go with positives here? As long as we go in the same direction, we can make them positive. If I made this negative and negative, would we come up with the same answer? We would. Okay? All right. So let's look. We can say that Y equals V naught Y plus 1/2 18. Because our V naught Y is 0, then we, you know what, I messed up there. We should have V naught Y times T. But now it's 0. It's still going to go away. We plug in our 18 meters, our 9.8. We solve for T, and that ball is going to be in the air for 1.91663 seconds. Okay, which allows us to answer question A, how long is it going to be in the air? Okay. Now question B, and what I'm going to do over here, it says how far from the base of the cliff does the ball hit the ground? Well, this is easy, guys. Super easy, because in the X direction, it's always going what? 20. If it's always going 20, and it's going 20 for this many seconds, isn't that a pretty simple constant velocity type problem, where we say 20 meters per second for a time of 1.91663 seconds? We just multiply those two together, gives us our distance traveled. So from the base of the cliff, this X right here is going to be 38.3326 meters. That is pretty straightforward, don't you think? Okay. And then, the last question is kind of the hardest question. What is the velocity of the ball the instant before it hits the ground? Well, guys, in the x direction, we know that's easy because it's 20. It's always going to be 20 in the x, right? The only other thing we need to find is the v naught y, which is really pretty simple because it's just a simple kinematics problem. It's no different than the rifle drop the bullet problem that we talked about last week, where if I shoot the rifle and the bullet comes out, if I shoot it horizontally, are they going to hit the ground at the same time? If one comes out of the gun and I just drop one? Okay, so really, that's all we're going to do is we have v naught y, ay, we have y, and then we're looking for vy. So we choose the kinematic equation that looks like this. Vy squared equals v naught y squared plus 2ay. V naught y goes to 0, so we plug it in there. We solve for a y velocity of 18.783 meters per second. Okay, and then guys, I'm going to switch over here because I can't get over in the corner there. If we want to find the velocity, we know this is 20. This is Vx is 20. And we know this is Vy when the instant before it hits the ground. And then guys, this becomes a simple trig problem that we've been doing for all year. That squared plus that squared is going to be equal to Vy squared. So we set it, I'm sorry, well, not Vy, just V. And so we solve for V. X squared, Vy squared, comes out to be 27.44 meters per second. And then we use some right triangle trig. We have opposite and adjacent, so we go with tangent. We take the inverse tangent, we come up with 43.2 degrees. Okay? Now this is pretty important. Listen to this because some kids get confused here. I think the magnitude piece is pretty easy. We know the x, we know the y, we square them, we take the square root, we add them together, we take the square root. That's pretty easy. Getting the angle is pretty easy, I think. But then some kids get confused because it's not north of south, east of west like we've done before. This is going to be what? This theta is below the horizontal. Does that kind of make sense? So I've written it as 43.2 degrees below the horizontal. Does that make sense? Okay. Guys, I think not a difficult problem at all as long as you kind of break it into its pieces. In every one of these kinematic equations, the first thing you want to always look to do is determine the time, how long it's in the air. Because if you know that, then you can always multiply by the velocity in the x to figure out how far it's going to travel.